So we have a machine element as shown, and we have to determine the safe value of thickness of plate. Okay, these are the given conditions according to here 500 kilonewton force is applying, and there are two nodes on both sides, and there's a hole. Okay, and symmetrical hole is also present at the both side of the plate, and we have to design or find the value of thickness, safe value of thickness. What thickness should I make this plate under this condition not to be fail proof? Okay, that's what we have to find. And the material selected for this machine element, it has a design stress or maximum stress is has to work is 200 megapascal. Okay, so these are the condition, and we have to determine the thickness based on this. So this type of problem has to be done in two different cases. The first case is considering the hole alone. Since we are not asked to find the total stress, okay, there are holes in the part, so I need to take this section two. I mean, like I have to take it two times, right? Because these section are present at the both the end of plate. But we are asked to find the thickness, so only we need to consider this hole case and notch case. So first case is this. If you observe this plate, it's having a hole, plate with hole on both side of the plate. So it is only necessary. We should only take only one part. Okay, we don't need to take both. The both are same. So we only need to take a single case of this plate with hole. So we take this plate with hole. It's already given the question. It's 30. This the hole is having a diameter 30, and this hole breadth or width is 220, and it is subject to a force F. So the basic formula for axial load is F by A into KT. The force is given in this question is 500 kilonewton, and the area have to area is simply this breadth into thickness. But since we are having hole, we have to exclude that distance. So that is B minus A. B is this total distance 220, and A is this diametrical distance. So we have to exclude this distance of this hole uh, regarding the breadth. So B minus A into thickness. That will be 190 area. So in this type of problem, we need to find A by B. Okay, we have this corresponding. You have to check the design data book with this corresponding figure. You would find it, and for this type of cases, plate having center hole, we need to find a value of A by B, where A is the diameter of the hole and B is the this diameter, this distance. Okay, this vertical distance. So you'll be getting 0.14, and with that value you can plot from the graph and find the value of KT stress concentration factor is 2.65. Then you need to find the thickness, right? And they already given the maximum design stress as 200 megapascal, or that means the maximum stress that this it can work. So we can substitute that in this equation, because we can substitute that in the value of sigma max. So 200 is equal to this remaining all these terms, substitute the value and find the thickness. So for a plate having this actual condition, the thickness, the safe thickness will be 35 mm. This is the first case considering the hole alone, but you need to consider the notch too, right? So considering the notch, same case you can find in the data book. This type of question you can find in the data book. So for notch, same way we need to find the area. Area is the thickness T into 160. This is actually 220, but we need to exclude, just like the whole, we need to exclude this both fill. There is no material in this, but we have to exclude this both distance. That is 30 plus 30. This 30 and this 30 has to be excluded from the total 220 distance. So 220 minus 60. So 160 is the remaining breadth into same like thickness. So T into 160 is the area. In this type of plate having these two notches, we need to find the value of R by B and D by D or B by B. Both are same. So D in some textbook, this capital D means this vertical distance. Small d is the distance excluding the notch. For some texts, it is written as capital B and small b. In the case of capital D and small d. So both are same or with respect to the different data book. So finding the value of this R by B and this B by B or D by D, you can find the stress concentration factor in the corresponding graph in the data book. If you got the value as 2.05, so substituting Just like the previous question, previous section, we have to substitute the sigma max, the maximum design stress which is given in the question 200 megapascal. We have to substitute in the same place and find the thickness of 32 mm. So we have two thickness. Considering the hole alone, it is 35 mm, and considering the notch is 32 mm. So we have to choose only the maximum condition to be fail proof. So thickness is 35 mm to design.